All right, where do we want to start?
Hi, Dr. McBride. I'm not sure if I'm just messing something up, but I was wondering if you could show me how to do two box plots on,
Side by side?
yes,
Yes. Okay. And that's the mini project data,
that's
isn't
on
it?
the mini project, yes.
Yeah. Okay. So what you need to do for that one is you need to use the other data set that I provided you guys. And it is the BP categorized data set. And the reason why you need to use BP categorized is the only way to get a side-by-side box plot is to have all of the data in under one variable name, and then you have to have a categorical variable to delineate, which data set it came from. So for instance, this one came from BP before, these were all BP befores, and then down here, these are all BP afters.
Okay.
So that's the big thing that you have to do in order to get SAS to do it, because it can only do it if you load a variable, one variable, and then one categorizing variable. Okay, so make sure you upload that data, right? And then you'll see that you'll have two variables, BP and BP cat for BP categorizing. And then if you go to task and utilities, go to your friend, the box plot, pick your import wherever you want. Your analysis variable, of course, is going to be BP. Then you have your category variable, and that's where you put BP cat. And if you run that, then you'll get both of them in one graph.
Thank you so very much.
Absolutely, that's what I'm here for. Yeah, so that's I noticed one person who had sent in their report just had two graphs of each individual one next to each other. I'm like, oh, cute, but that's not technically a side by side. You have to do it this way, and then unfortunately, you'd have to do some recoding of the data yourself if I hadn't already done it for you. And it's a pretty easy thing to do, right? You just put your data in here, and then put before and drag it down, and Excel copies before a bunch of times, and then you paste the after and you type in after, and then you drag that one down and it creates a bunch of afters, and then you're good to go.
Dr. McBride, do you want that in horizontal, or you don't really care?
Oh, you know what? I don't mind. I think the horizontal always looks better. So yeah, go ahead and do horizontal. The reason why is because then it fits the, it's like it's sitting on the number. But I wouldn't take points off if it was either way. I'm not, that big of a jerk.
Okay, thank you.
Yeah. Michael?
Yes, as far as the explanation, you just want a short sentence or two
Yes.
regarding the correlation, correct?
Yeah, absolutely. Yeah. So for all of the questions, basically for each of the letters, you make some graphs, and then you do a sentence or two describing them. So if it doesn't actually ask for you to interpret it, then you just do a sentence or two kind of describing what you see. Is there anything interesting, or is there nothing interesting? Because that's also interesting too. So is it, like for instance, when you do the frequency tables, you could say, oh wow, this one category had a lot more than the rest, or all the categories seem to be evenly spread. That kind of just basic analysis. And then for the ones that ask you to interpret it, then yeah, a sentence or two interpreting it. So nothing, extremely verbose, just looking for a couple sentences here and there. And if you guys want to, you can do those explanations like under each graph, or if it's a question that has multiple graphs, then you can do it at the end of the multiple graphs, especially if you're going to kind of talk about all the graphs as a group. Then that would be the more logical place to put your couple sentences. Or if you want to, you can just put all of your results, and then at the bottom do 3 or 4 paragraphs, however it takes to describe each thing. It's up to you. Dennis, you were next.
Thanks, Dr. McBride. So I was going to ask about, I guess it'd be the fourth one. I guess I'm a little confused on when it says create a clean table of your results with everything in correct order. I was a little not sure about that.
Okay. So let me see what that one is saying.
I can kind of say what I did because I kind of struggled with that too, but I kind of, because it asked for the 5 num summary, then standard deviation, and then mean or something else. So what I did was I made like a little Excel chart and listed all those, and then to the right listed each variable, and then put the numbers in just so it was kind of, I
Yes.
guess, easier to look at. I guess.
Yes.
I'm not
So
sure if that was right all the
no, that's
way,
pretty
but
much it, because see what's going to happen is when you run the data in SAS, so for instance, if I just loaded, let me run my data so it's loaded. It's in import 1, right? So I go down here and I go to summary statistics. That's basically what we're doing, is we're doing summary statistics. I pick up my data 1. Remind me, they want it on all 3 of these, don't they? Age,
I
BP.
think it was age, BP before, and BP
Yeah,
after.
I think it was all 3 of those. Yep. So I put all 3 of those in here, because if you didn't know that, you can put more than one variable in here, then they'll all be in the table at once. So you can do it all in one table, which is kind of nice. Now for the options, they wanted the mean, the standard deviation, they wanted the min, the max, they wanted the median. They didn't necessarily want number of observations, but it always gives you that anyways. And then they wanted the 2 quartiles, right?
Yeah.
They wanted the lower and the upper. And that's all they wanted, right? They wanted the mean, the standard deviation, the mean, the median,
Yeah.
the 2 quartiles. Yeah, so this should be everything. So if I run it, this is what's going to happen. It puts it in a table like this. It gives you all these extra zeros that you don't need, and it puts it in an order in which you don't want. So what you should do is, copy paste this, put it in your report to show that you did it in technology, and then make a prettier one. And a prettier one is just making sure that it's in order, right? It should go, so the 5 number summary should go minimum, lower quartile, median, upper quartile, maximum, and then at the end, mean and standard deviation. That's how it should go as far as the ordering is concerned. And then it's up to you whether you want to make your table vertical or horizontal. And by that, I mean, this is a horizontal table because it's horizontal, meaning that your 3 variables are stacked horizontally, and then all of the results are, in these columns. So this is a horizontal table. A vertical table would look like, let me show you. Da, 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 da. Where are you? There you are. Okay. This would be the same table, only considered a vertical table,
Oh,
right? And it's really your own preference. Are you guys not seeing my screen?
No, I see it.
Yeah.
I see
Okay.
it.
Okay.
I see it.
Raven, you might want to log out and log back in if you still can't see my screen. So yeah, so it's really just a personal preference as to which one you like. There is an actual there are APA rules as to which way you should do it. And I actually, when I did my dissertation, I bought this beautiful little book that I love. That all it is, of course I had the APA manual, but in addition to that, I had this little green book that was basically how to display your results. Where the heck is it? If I can find it here real quick, I can give you the info on it, and then you guys can, there it is. So it's just called Presenting Your Findings, a Practical Guide for Creating Tables. And it's great because whatever you want to do, you can look it up, and then it'll show you properly APA formatted examples of tables. So like I would look up summary statistics, and it would show me different kinds of summary statistic tables. And then that way, you kind of know that you're doing it the right way, because there are actual rules as to how these are supposed to be done. Now, am I going to hold you to those rules? Hell no, because again, I'm not that much of a jerk, no matter what you guys say. But if you want to take the time to, kind of go that route so you can get ready for your dissertation later, then by all means, go for it.
Is this
But
what,
I would accept either one. Sorry, I think I
sorry,
stepped on something.
Dr. McBride, is this how you want it in the mini project, or is it okay if we do it horizontal?
Oh, either way is fine with me.
Okay.
Yeah, I think APA would say it should be the lower example. But I don't care at all. Okay, who's next?
And I do have another question if someone's, if that's okay.
Yeah, go ahead.
3.56, is 3.56C similar to what you just described?
3.56C.
It states compute the standard deviation and the expenditures separately for each of the 5 groups. That's A, but C talks about the method by which the standard deviation for the combined data set could be obtained from the 5 individual standard deviations.
So that's similar to the question we had last week, where we had the 5 means, 4 or 5 means for the different groups, and then it said also compute the mean for the whole set of data, which you could do by taking the grouping variable out in SAS. And then after that, it asked, okay, how could you obtain that mean from the 5 group means? And we had to do a weighted mean, right, where we took each mean, we multiplied it by its sample size, we added them all together, and then divided by the total sample size.
Yes.
There's a somewhat similar process that you could do with group standard deviations, but it does not work perfectly. Like a weighted mean works perfectly. You guys saw that if you did it, you got the exact same answer as the actual
Right.
group mean. However, in this instance, if you do a semi kind of weighted mean, the first thing you have to do is you have to take all your standard deviations and you have to square them and turn them into variances. Then you have to take every variance and you have to multiply it by the sample size minus 1, because that's basically how it was computed, when you made the standard deviation, because these were samples, it was divided by the size of the sample divided 1. So you have to multiply it by the size of the sample minus 1. That's kind of the weighting that we did that we did with the means. Then you add all those together. So basically you have all the variances, which is just the standard deviation squared, right? So you have all those multiplied by their corresponding sample sizes minus 1. You add all those things together, then you divide by the total sample size minus 1. Then you take that answer and square it, root it, right? Because that is when you do all that, you get an estimated variance, and then of course you square root it to get you back to the standard deviation. And if you actually do the math, which I suggest you guys should give it a shot and see what you get, it is not the same as the standard deviation you get out of technology, because that process does not work. It gives you a close approximation. And so what it does is it shows you that you can get a close approximation, but you can't get the actual full set standard deviation that way. So if you were, and the only reason why we're doing this is oftentimes you'll be reading a research paper and they will only list the group means, or they will only list the group standard deviations, and you want to know something about the whole set. Well, you can compute the mean of the whole set from those statistics, but you can't get the standard deviation of the whole set. You can only get a close approximation. So that's kind of the thing that we learn from these 2 examples between these 2 homework sets. Does that make sense? I mean, does that answer your question, Michael?
It does.
Okay. Seth, you still got your hand up. What's up?
So my question is on the exact same one, 3.56 part C. I've spent like a considerable amount of time on this today, and I've only come within like 1 or 2 of the standard deviation that I could get from
Yeah, you can't.
SAS.
Yeah, like I said, it doesn't work. I mean, it gives you kind of the best approximation you can get, but it really doesn't work.
Could you unless everybody is opposed, would you mind going over how you would do that? Because I think it'd be really valuable, like in the future, to know
Well,
that
in the
process.
future, I would never do it, to be quite honest.
Okay.
just because I'm not a fan of approximations. I'm a statistician. I'm a math geek, and I like real numbers. I don't like approximations. It's one of the reasons why I hate that we still teach how to approximate the binomial distribution with the normal curve in statistics classes. I'm like, why the hell are we approximating things when we can just run the freaking binomial? We have technology. The only reason why we did this was 75 years ago when technology wasn't around here and we had to actually compute these things by hand. We could approximate it with the normal curve because we couldn't do the big ass binomials. Well, now we can do big ass binomials, so just do it the real way. But it basically, you take each standard deviation, change this. I can make it the red pen. I think it's a normal pen. You take each standard deviation, you square it, which becomes the variance. You multiply it by its corresponding sample size minus 1, right? So you can think of this like standard deviation 1, sample size 1, plus standard deviation 2 squared times sample size 2 minus 1 plus dot, 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 dot. You take all that crap and then you divide it by the total, right? The big sample size minus 1, and then you take the square root of that whole thing. And that's as close as you're going to get, and it's going to be a crappy, like you said, it's going to be off by a point or two. So it's all you can do. As far as doing the work, I would do it in Excel. Because you could have the results. You can paste the results or type them in, and then this is just going to equal this thing squared, is the first thing you do to square it, and then it's going to equal this thing divided by whatever the sample size is, 15, right? And then once you do that, then at the bottom here you're going to sum them all up, and then this one's going to equal that thing, square root of that thing, and then this one's going to equal that thing, or sorry, this one's going to equal that thing divided by its sample size, and then finally you're going to take the square root of it. So I would do all the computations in Excel rather than trying to do it by hand.
Okay, thank you so much.
Yeah, absolutely. Rachel.
Sorry about that. I was having trouble coming off mute. Okay. I'm sorry to take us backwards, but on the box plot where the two were next to each other, I got the same graphic, but I did it totally differently. And I want to make sure I didn't screw something up here.
Oh, wow. Did you do it with code?
Well, I used the output data set and I stacked the columns, and then I just ran the box plot on the new output.
Okay.
Does that make sense?
Not at all. But if you got, but I'm not an expert, but if you got something that looked just like this, then you're fine.
Okay, because you can stack the two columns together so that from the original, I didn't even notice that there was a sorted data set, which makes me feel really stupid. But
oh, you mean you stacked the two columns of data?
Right. Mm-hmm.
Oh, yeah, that's exactly what you needed to do. Yes, yes.
Oh,
I thought
thank God.
I thought you were stacking the
No.
graphs. I'm like, how the hell do you stack graphs? Okay.
No.
Yeah,
I
yeah.
stacked the columns.
Yes. That's awesome. That's exactly what you needed to do. Yes.
Okay. Whew. Thank
Well
you.
done.
That's all.
Yeah, nicely done.
I was hoping to see
Could you go over that one again?
Sorry. Montrese, did you want me to go over this one again?
Yes, because I came in to see how you was doing it, but when I did it, I didn't get the same graph that you have. So I was trying to see where.
Did you use this other set of data, the BP categorized set of data that I gave you?
Oh, that's it right there. Never mind. You don't have to do it. I know exactly what it is.
Yep.
Thank you.
No worries. Rachel, your hand's still up. You got another question?
No, I'm just trying to figure out how to get my hand down.
How do you guys get it down? Do you click on it?
I got it.
That works.
Sorry.
There it is. Nope, you're fine. Okay, who's next? Is it Taiwan?
Yes.
Okay. Go ahead.
On the homework 3.29, the quantile plot, I was having problems with that.
Yes, the quantile plot is not easy at all, but it's super easy if you just because we used to have to do it with coding, and it was a big pain in the butt until one of my students was like, hey stupid, there's a way to do it in the menu system, and showed me how to do it in the menus. And I was like, oh, this is so much easier. So here's the data from 3.29. I loaded it, right? I always like to look at it and see what I've got. Okay, so I've just got one variable called treatment time. So now if we go to tasks and utilities, and let me close everything so you can see where it comes from. Under the SAS how-to guide, if you go down here to week 3, Quantile Plot, it shows you how to do it, right? You go to task, statistics, distribution analysis. So under tasks, we go to statistics and then distribution analysis. So we're going to double click on that. Then we have to choose the right data set, which is that one. Of course, we have to add our analysis variable, which is just treatment time. And then let's double check if there's anything else we have to do. Options, checking for normality. You need to check the normal quantile plot and then add the insert statistic and run, excuse me. So under options, we go down here, checking for normality, normal quantile plot, add insert statistics. Down here, you can say what kind of insert statistics you want. If you want to check for things, like you can do mean and a goodness of fit test. And that's probably about it. And then run it. So this is the first thing it gives you. It just gives you a distribution, right? So you actually get a nice little like histogram distribution if you needed it. And you can see from the distribution, oh, in fact, I'm not going to say it. You guys tell me, from the shape of this distribution, is the data normal or is it skewed? And if it's skewed, is it skewed to the left or skewed to the right?
It's skewed.
It's skewed
Which way?
to the right.
Right.
Very good. Awesome. You
Right.
guys are great. Skewed to the right. Fantastic. And then here is your QQ plot. This is your quantile plot. So this is your normal quantile plot. And you can see from it that it doesn't have any obvious pattern, right? It's not kind of like going zigzagging along the line. The dots line up fairly decently along the line. And then you have the tails that just kind of trail off, which tells you have a little bit of a skew, which you do, right? But for the most part, this is fairly normal, right? It's a fairly normal distribution. It's just a little skewed. And that's what the quantile plot tells you. So your normal test statistic right here, 0.95, and then the normal test p-value. So this is great because this tells you this, to me, this is the best way of knowing if it's normal or not, right? Interpreting a quantile plot, I never thought was very easy. It was a little bit too subjective. And then you can even get these skewness numbers to tell you how skewed your data is, but even those, interpreting those is not the easiest thing in the world. But this is pretty damn cut and dry. This is easy to interpret, right? If you know anything about hypothesis tests and how hypothesis tests work, then when you get this p-value, you know exactly what's going on, right? And so what this is it takes your data and it runs a normal test. It basically runs a hypothesis test on whether or not your data is normal. And your null hypothesis is always equals. So the null hypothesis for this test is that your data equals normal, right? Your data is normal. And so it's testing that hypothesis. And then if you get a very, very small, I'm sorry, it's testing that your data is not normal. And if you get a really, really small data or really, really small, oh shit, is it the other way around? Maybe this does say it's not normal. Crap, now I forget. I think it does test if it's normal. This tells you because it's small that you reject that, and it is not a normal distribution because it is skewed. But it's not, that badly skewed. I mean, really, if let's put the median in here. Let's see what the difference is between the mean and the median. Yeah, I mean 20.3 and 19.5. That's nothing, right? You can do skewness and standard deviation, run that. So here's that thing for skewness that I was talking about, and I think there's something like you want it to get closer to 1 means it's not skewed or something. I don't know. It's confusing. But the bottom line is it's normal-ish. It's normal enough, right? I think what this tells you is you definitely reject because it's, it's so small. But I thought the null hypothesis was that it was normal. So I guess you reject it, meaning that's not normal. I'll have to research that, see what it's doing here. Because to me, that should have come back with a relatively normal result, but maybe that's a pretty strict test. Let's see what the normal probability plot does. Yeah, same thing. You can see that they're pretty much identical, right? The two graphs. So these are your normal percentiles here, and then here's where the treatment are. And if it was perfectly normal, these would basically just line up along this line. So you can see that it's off from normal, which I think is why it's getting rejected here. But in any case, it's normal enough if you were testing for that kind of thing. I always think, quite honestly myself, that QQ plots are kind of a waste of time. If I wanted to know if my stuff was normal, I would run a distribution like this, and I would run the mean, the median, and the standard deviation. And then you could also run skewness and then look up online what the hell skewness means. You can sit here, you can literally go, how do I interpret skewness and kurtosis? And it'll talk about right here, right? General guideline for skewness is that if the number is greater than 1 or lower than -1, this is an indication of a substantially skewed distribution. And ours was in between that, right? It was like point something. So that means it's not skewed enough to consider it to be hyper skewed, severely skewed, but it's definitely somewhat skewed. But you can also see that from the difference between the mean and the median and go, okay, well, they're a little different, but they're not hugely different. So it's skewed, but it's only a mild skew. In fact, if I look at the standard deviation, the difference between these is less than 1, right? 19.5 up to 20.3, that's like 0.8. That's a tenth of a standard deviation. So these are off by a tenth of a standard deviation. That's a tiny skew. So this picture, along with these statistics, would tell me that my data is normal enough to be treated as normal. And I wouldn't even bother with a QQ plot. That's just my own preference. Just because, if you publish this, 99% of the public would go, I have no idea what the hell that means. Right? But if you publish a histogram, most people go, okay, I can look at that. And at least probably half the people go, oh yeah, I can see that's a little skewed. So it's just a lot more informative. Okay, does that answer your question?
Yes, thank you.
Absolutely.
This is Kim. Can I ask one question? Can you go back, because I'm trying to run this and I'm having a little problem. Can you go back to the data section that you have here?
For 29?
Yeah, for 29.
Yeah.
And because let me see, because I'm not for some reason getting this same thing here. Let's go 329. Yeah, because
it's your treatment time.
Huh. Okay.
Are you doing distribution analysis?
Yeah.
Okay. And then under data, all you do is choose treatment time and nothing else on this page. And then everything else is done under options. Under options, you have to go, you can take the histogram off if you want, you won't get this. But what's important is under checking for normality, you need the normal quantile plot.
Okay.
And that's all you need. The rest of the stuff I just do as a teaching tool, right? If you turn all that off and just ran it this way, and even if you turn the histogram off and got only what you needed, that's literally all you need for that. To satisfy that homework question.
Okay, so that comes, gotcha. All right, that worked out. For some reason it wasn't picking up, but now it is, so.
Okay, cool.
Thank you.
No problem.
So Dr. McBride, for
yes, Alice.
letter A for that one, you said to find the 25th percentile. I was fine with doing that, but it says to interpret this value. Do you want me to just talk about finding the 25th percentile? I wasn't sure what you meant by interpret this value.
Yeah, I mean, interpret what the 25th percentile means in terms of the data, right? It means that 25% of the patients are seen in that many minutes or less.
Okay, that was easy enough. Okay.
Yeah, and the reason why I want you thinking about that is because later on in that question, it asks you about their claim that 90% of their patients are seen in under 40 minutes. Well, if you run the data and run the 90th percentile, you'll calculate the 90th percentile as being 31.5. And so I had a lot of people turn in their homework and they would say, yes, their claim is true. And my response would be, why? You know, you can't just say yes. Why? You know, how does your data support the claim, right? How does your data basically, quote unquote, prove? I just don't like using the P word because we don't prove anything in statistics. That's why we say support. How does your data support their claim? Well, my data shows that 90% of the people, right, because of the 90th percentile, 90% of their patients are seen in 31.5 minutes or less. They're claiming 40. Well, 31.5 is less than 40. So 90% of their patients are definitely being seen in under 40 minutes.
Right. Okay.
Yeah. So that's what I'm trying to get. That's what I'm trying to get from you guys, because then that means you really understand what's going on. All right. Are you good?
Yes, sir. Thank you.
Awesome. Dennis, your hand's up.
Yeah, Dr. Murray, can you possibly demonstrate the mini project, the Generate Histogram?
Yes.
Thank you.
Are we supposed? We're supposed to do histograms on the 3 quantitative variables, aren't we? The age, BP, and BP after.
Yes, that's correct.
Yeah. Okay. So graph, histogram. Where is my mini stuff? Work 1. All right. Work 1. Analysis variable. Unfortunately, with this histogram function, it will only let you do 1 at a time. You know, you can't put all 3 in there like you can for summary statistics. So you just run this one. There it is for age, right? And then swap it out. Put in BP before. There it is for BP before, and then swap it out and do BP after.
Okay, yeah, I thought for some reason we might have to change the bin start and the bin list, but not the case.
No, these all look pretty good when you run them. There's you can manipulate them as much as you'd like, but just the standard one looks fine.
Okay, thank you very much.
Yep. Who's next? Jacqueline?
I'm sorry.
Sorry, I just saw Jacqueline's hand next. Oh, no.
I didn't know if anybody else had hands raised or not yet.
Yeah.
But okay. As I didn't have any homework questions, but the article question.
Sure.
On the I was starting it today and I was starting to put it like as an essay. I mean, not an essay, as a yeah, as
discussion
an essay,
post,
like a document. Yeah,
okay.
and then I looked at then I could put in discussion post just the question and the answer. Do you want that into the discussion post or do you want our actual paper?
So
it doesn't matter.
What I want you guys to do, there's 2 things. So the research article does actually have a discussion component to it. So you can see here the research article critique is where you want to do this, right? Your initial post, right? Create a post in the discussion board and basically just answer these things. And that's what your post is.
Okay. For
which
the
is
discussion post.
Yeah, which is pretty much, you know, what you kind of did in the critique anyway. So it really, you can just copy and paste mostly. And then you go back and you read other people's posts and then you post 2 responses to those for the full 150 points for that part, right?
And then the actual paper goes to the turn it in.
Yes, exactly. It goes to turn it in and then, yeah, you got it.
That helps. Thank you.
Yep. Cecily.
Good afternoon, everyone, or good evening, I'm sorry.
You're fine.
I had a quick question related to the mini project, and the first item was generate the frequency tables for the 3 categorical variables.
Yes.
So when I did this, I'm sorry, let me decline this call. When I did this, it had, it says it also generated the bar graphs. You're not
Yes.
looking for the.
No. Yeah, it generates a bunch of extra junk you don't need. Just the three
Okay.
tables is all we need. And of course, the three categorical variables are.
They are gender, family history, and treatment.
You are absolutely correct. Perfect. Well
Okay.
done. Yes.
Thank you.
Thank you.
I think I thought I had another question. If I think of it, I did. If I can ask that now, if
Sure.
everyone will.
Yeah,
allow
you're
me.
fine.
Oh no, sorry, you already answered that. Thank you so much. I'm done. Thank you.
You're fine.
Okay.
Dennis, your hand is still up. Do you have another question?
Yeah, I do. Sorry to.
No, that's
take
fine.
all the time. I just wanted to, so that last question I asked about the generate histograms, does that apply to the homework 330A as well, not to mess with anything else?
Yes. Yeah. Any histogram, whether it's homework or whatever, if you run it and it looks fine, you don't need to mess with it. So the early ones, the only reason why we messed around with them in the early ones was A, to learn how to do it, and B, because that data looked crappy if you didn't.
Gotcha. Thank you.
Yeah. Yep. Absolutely. Micah.
Dr. McBride, I'm going to go back to the mini project with the histogram because I was looking back over how I did it, and I don't know if I fudged with the bin numbers in the actual code, and of course mine doesn't look like that at all.
That's fine.
But I need to go back and change it. But I do have a question when the actual skewing the information to the right and to the left, and then basically when there's more than 2 peaks in there.
Yes. So the easiest way to tell for sure if something is skewed is to run summary statistics on it, right? And the skew is always in the direction that the mean is pulled. So if the mean is larger than the median, we know it's skewed to the right. And if the mean is smaller than the median, we know it's skewed to the left. That's cut and dry, simple, easy. So I always tell students, if you want to know if your data is skewed, run the mean and the median and compare them. Because I look at this graph and I go, well, this tail seems to be a little bit longer, and this tail seems to be a little bit shorter. So if there's a skew, I'm thinking it's probably to the right. But if I run the summary statistics, for all I know, it could actually have a mild skew to the left. You never know, because like you said, if you futz around with the bins, you can make this thing look hugely different, right? And as far as that's concerned too, don't worry about wasting a lot of time going back and changing yours. If you ran it in the code and you had different bins and yours looks different, that's fine. I'm not going to take points off for it. As long as you made a histogram for each of those 3 data values and it looks halfway decent, then you're fine. Because you, like I said, you could mess with where the bins start, and you could do all sorts of stuff with this and make it look substantially different, which is totally fine.
Okay, because I was very concerned because it didn't look anything like what you. But
Yeah.
I did do an analysis on it, but I wanted to make sure that what I did was on the right track.
Yeah, absolutely. As long as you did an analysis and you talked about the skewness and the shape, and like you said, the one that has 2 modes or 2 peaks, you can talk about that. I don't think the peaks are the same if I remember off the top of my head. So it's not technically bimodal. I think it was this one that has the 2 peaks. No, I can't remember what it was, but I know what you're talking about, that you can get 2 peaks on one of these. But I don't think they're equal peaks. So it's not technically bimodal, because bimodal would have they'd have the same frequency. There's like if you went back and ran the mode in the code, remember when we learned that we had to run this separate code to actually find multiple modes, you could run that on your data and see if it actually has multiple modes, and I'm pretty sure it doesn't. And so it's not technically a bimodal, but you could say that the distribution has multiple peaks, or the distribution is skewed. We often refer to distributions that have 2 peaks that maybe aren't necessarily the same height, so they're not bimodal. We'll talk about it as being a dumbbell shaped curve. Things like that.
That helps. Thank you.
Absolutely. Alice, you're up.
Okay, thank you. Can we go back to the homework? I wanted to I'm kind of confused on 3.30 letter C.
Okay.
Calculate S for the data. I was able to do that, but I'm kind of hung up on the count the percentages of squares.
Yes. So what you do is you calculate the mean, you calculate the standard deviation, and then you create those intervals where you take the mean plus and minus the standard deviation, and that gives you an interval, you know, a
Yes.
low end and a high end. And then you
Yes.
do it again with 2 standard deviations and 3 standard deviations.
Okay.
And those intervals will be decimals, right? They'll have decimals to them, but our
Correct.
data set is whole numbers. So for instance, the very first interval is like 5.744 up to 9.713.
Mm-hmm.
Well, our data values are all whole numbers. So if you
Right.
want to find out how many data values are in between those two numbers, you're really just counting up how many 6s, 7s, 8s, and 9s you have, right? Because
Okay.
5 is technically too small, it's outside that interval, and 10 is outside that interval. So you would want to just sort the data in Excel is what I would do. And then I just go and I scroll down till I find the first 6, and then I click on that and I highlight all the way through all the 9s. And then in the lower right-hand corner, it gives me a count, and it just tells me how many data values were between 6 and 9 inclusive. It ends up being 50. So I'll give you that first one. So go and run it and count it and make sure you find 50. And if you find 50, then you've done it correctly. And then, of course, your answer isn't going to be 50. It's going to be 50 divided by 70, which gives you 71.43%. So you would say, okay, my first interval has 71.43%. The empirical rule says I should have 68%. So it's close, but it's a little big, right? So my distribution is a little narrower, right? Because it's getting more stuff in that interval than a normal curve would.
Okay.
And then you repeat the process with the second one. You calculate that interval, you count how many are in that interval, you turn that into a percentage, and then you compare it to 95%, right? And then you do the third one, you compare that to 99.7%.
Okay. Yep. That's kind of what we thought, but I just wanted to be sure. So
Absolutely, that's what I'm here for. All right, who's next? Alice, do you have another one?
No, I just
Okay.
needed to raise.
Nope, you're fine. Kofi, you're up.
Yes, sorry to take you back to 3.29. When I do whatever you've done, follow the steps, I see that my mean median is on the histogram instead of on the quantile plot. I don't know what I'm doing wrong.
Okay, so you need to do the inset statistics. So when you come down here, click on add inset statistics on the normal quantile plot, and then tick whichever statistics you want, right? I would say probably all you really need is the mean and the median to know what's going on. And then when you run that, it'll show up inside that graph.
Okay. I'll try it again, but I thought I had done the same thing.
Yeah, it's just it depends on where you click on things. So like if you click on the histogram and goodness of fit test up here and then click on add insert, then it's going to show up inside the histogram.
Okay.
Right?
Right.
Whereas if you do it the other one, it'll show up in the other one.
Okay, gotcha.
Yeah. Is that good? Okay. Rachel, you're next.
Okay, so I know we've talked about this and I apologize. I just want to make sure that I'm getting the answer correct. So on the questions where it asks you to compute correlation coefficients and to do the computation, it is okay if we did that in SAS, correct?
Oh, please. Yeah, absolutely. I wouldn't, I mean, I wouldn't want you to do it any other way other than I guess maybe Excel. I sure as hell would hope you're not doing it by hand.
Well, on the first one, I did spend a lot of time this afternoon and I found exactly what you discussed earlier, that I just couldn't make the numbers match what I found in SAS. So I just stuck with SAS as my responses.
Oh,
But
I see what
then,
you're talking about 356.
well, yeah,
The
with
standard
that one,
deviations.
with that one, I just kept going, trying to get it, but I couldn't get it exactly right. And then with the other ones, I was like, oh, you know what? I'm just going to use SAS because I know I can get the correlation coefficients.
Okay. Yeah,
And I
because
just wanted to make sure
that's
that that
different
was
than the
okay.
standard deviation, right? Because the standard
Right,
deviation question, we're basically doing this formula here
right.
to get the standard deviation, whereas the correlation one, we can just run correlation analysis right here and then put the variable, and the variable it correlates with. So for 3.69, right, you're putting in AIDS and syphilis, and then
Mhm.
for 380, you're putting in price and airflow. Exactly.
Right.
Yeah, and it'll spit out a little tiny table, and it'll show
Right.
you the correlation. Yep, that's all you need to do.
Okay,
That's
I
totally
just
fine.
wanted to make
Yep.
sure that's all you were looking for. Okay.
Absolutely. Absolutely, totally fine. Yep. I do know there is a way to get the scatter plot with a regression line and the correlation in a little inset like we had with this one, right, in this little box. But I can't for the life of me figure out how to do it again. So if anybody can figure out how to do that, share with the class. But it's totally fine to just run the scatter plot, by doing this the scatter plot thing, and then run the correlation analysis the other way. Yeah, I don't think there's, yeah, because you can fit a regression line, but I didn't see anywhere in here where you could get the correlation out of it. But I thought there was a way to do it, but don't waste time trying to figure that out unless you got nothing better to do. Okay, who's next?
Dr.
Michael?
McBride?
Yes.
When can we, when's the latest we can turn in the mini project for review?
Tomorrow night.
Tomorrow night, okay.
Because it's due this Sunday.
Okay.
Rachel?
It's my computer. I'm sorry. I can't get myself off back onto mute.
I can mute you.
Thank you.
Yep. I can even lower your hand. Taiwan.
Yeah, on the mini project, I'm having problems with the
Oh, sorry, you got muted.
I'm having problems on the mini project with the category variables.
Ah, okay. How so? Like you don't know how to run the frequencies?
It's not letting me run the frequencies.
Okay. So where is my data? It is import one. Okay, if we do table analysis, right? Under statistics, I think it's table analysis. And then import one. Yep, that's right. And then the row variable would be, oh no, I'm sorry. I think this is how you get a cross table. Let me see, gender and family history. Let me run that and see. Yeah, that's how you get a cross table. So table analysis is how we get a cross table. How do we get frequency counts, kids? Somebody's done it. It's not just in summary stats, is it?
Is a one-way frequency.
Ah, there you go. One-way frequencies. Yeah, that would make sense. Toy, of course. And so then you can go gender, family history, and treatment. Add those in and run it. And there you go. So there's your frequency table. Ignore this crap, right? Ignore this crap. There's your frequency table for gender. Ignore all this crap. We don't need those things. And then there's your frequency table for family history. Again, ignore all this stuff.
Okay.
Yeah, so one-way frequencies. Thank you, whoever said that.
Thank you.
And then table analysis, as I showed, is how you do the cross tabulations. Okay, any other questions?
I have one very crazy question, and if it is, I apologize.
Well, of course it's a
So,
crazy question. You're a friggin' Alabama fan. You're
I
all
know.
crazy.
I mean, you know, we're all slow here in the South. So, for the mini project,
Yes, ma'am.
and the item number, action item number 4,
Yep.
annotate the output as a report. We're basically just giving narrative to the graphical information that's being presented.
You got it.
Correct?
That's exactly
Okay,
correct.
I just
Yes.
wanted to make sure
Yep.
I wasn't reading too much into this. Okay.
No, and that's where I've been talking about, you know, it's just a sentence or two for, you know, for each of your outputs. You're
Okay.
just summarizing what you're seeing, kind of thing.
That's better. Thank you so much.
Absolutely. Anybody else?
Dr. McBride, I hate to take us back. I really tried to find the information.
Yep.
But for the one with the double on the side-by-side box plots, I couldn't find the other data
Okay.
where you
So
got it from.
if you go to our Google folder, can you get to our Google folder?
Yes.
So in our Google folder, if you go to the, so from the main page, basically, you go to data sets and then data files by week and then project files. You'll see down here, mini project 1 BP categorized. That's the file that you're going to want.
Okay.
Because if you look at it, you'll see that it has all the BPs in one, under one variable name, which is what you need, and then you have a categorizing variable to categorize them. And that's what you have to have in SAS in order to run a side-by-side. So if you had 3 variables and you wanted to compare 3 variables, you'd have to put all 3 of them under one name and then obviously have a third categorization in here. So you'd have like before, after, and then, you know, whatever the third one was called. And then you'll have 3 of them side by side. And you can do that, you know, for however many of them you want in one graph. You just have to have all of your data under one variable with a categorizing variable.
Okay. Thank you.
Absolutely. Anybody else? Cicely.
I don't have a question. I just want to thank you for taking this time to go through all of this, and it makes it a little clearer.
Oh,
So thank you,
well, thank
Dr.
you for
McBride.
saying that. You guys have always been a great group, and thank you, Cecily, especially you personally for having a good sense of humor. It makes my life a million times easier if students allow me to poke fun at them. So I appreciate you having a good sense of humor and letting us poke fun at your Alabama-ness. Kim.
Can I follow her up by saying thank you for recording these? Because and I'm
Yes.
curious.
Yeah.
I sit here and listen, right? And I'm following along and I'm doing everything with you. And I find myself, and by the way, my husband is a SAS programmer. So this is like ridiculous for me. That I find myself going back to the video and telling him he's wrong, which is even better. But it helps me to be able, because I can fast forward, I